Good morning and welcome to our Speech AI Day event, an immersive digital event with industry visionaries and experts who will talk about their revolutionary research and real-world applications with speech and translation AI technologies. And before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use, and all the widgets are resizable and movable. If you have any questions during the event, you can submit them through the Q&A widget. We will try to answer these at the end of the event. A copy of today's slide deck and additional help materials are available in the resource list. We encourage you to download any resources or bookmark any links that you may find useful. You can find additional answers to some common technical issues located in the help widget at the bottom of your screen. An on-demand version of the event will be available approximately 1 hour after the event and can be accessed using the same audience link that was sent to you earlier. And with further ado, I'm handing to Matt, moderator, to our first session, Speech AI from Research to Production Fireside Chat.
Thanks, Gordana. This is amazing. I'm really excited to be a part of this event. We've got an amazing panel. If you don't know me, my name is Matt Wolf. I am a YouTuber. I run a website called Future Tools, where I keep up to date with all the latest tools and news in the AI space. And so I am just super deep in the AI space, keeping up to date with all the latest news and research on a daily basis. So really, really excited that NVIDIA asked me to help moderate this panel. And I'm really excited to introduce the panel that we have here today. And instead of me introducing each individual member and trying to tell you about everything that they specialize in, I'm going to go ahead and pass it around to each panel member and let them really quickly tell you about themselves. So I'm going to go ahead and start with who I see on my screen in the order that I see them. So let's go ahead and start with Shinji. Can you go ahead and give everybody a super quick intro about who you are?
Hi, I'm Shinji. I'm now working at the Carnegie Mellon University as an associate professor. I have been working on the companies for a while, in Japan in NTT for 10 years, and moved to the US, and then also working 6 years, and moved to the academia, the Johns Hopkins first, and then now I'm in Carnegie Mellon. I have been working on speech processing for 20 years, and I'm very excited to talk and discuss with you guys about the latest technologies. Thank you.
Thanks, Shinji. Let's go ahead and move on to Georg now.
Hey there, I'm Georg Kutzko, originally from Austria. My background is actually in experimental physics, doing research on quantum computing and quantum sensing. But for the better part of the last decade, I've been working in the field of generative AI and specifically in speech and audio. Currently now, I'm working on a new company called Suno, and we try to develop state-of-the-art speech and music generative algorithms. So think of Mid-Journey, but for audio. And thanks for the invite. Excited to be here.
Very cool. Thank you. Swapna?
Good morning, everyone. Good evening, good afternoon, wherever you are. I'm Swapnil Pillai, working in Wipro. I head the AI Center of Excellence, especially the Generative AI Center of Excellence. Now been in Wipro for 7 years, and overall working in machine learning and AI for last 20 plus years. And my areas of interest include, the machine learning, computer vision, NLP, and speech AI. And recently, my added areas of interest have been in the metaverse and, the 3D avatars, that sort of thing. Nice to be here.
Very cool. Thank you. And then Alexei.
My name is Alexei Ivanov. I'm very glad to be invited to such a representative panel discussion. I am a long time practitioner in the field. I started back in 1998. My first paper, student paper, went that year. I worked in academia at the University of Trento and Moscow Institute of Physics and Technology. I worked also in the industry, places like Educational Testing Service, NOS, Intelligent Audio, and now I am the Senior Principal Research Scientist of a newly formed startup, Hippocratic AI. Hippocratic AI is a company that aims to build synthetic nurse that specializes in efficient interaction and facilitating interaction between the end users of our healthcare system and hospitals, in explaining the benefits, providing seamless scheduling for the service, and letting the patients know all kinds of aspects of their treatment that they undergo in the hospital.
Perfect. Yeah, I can't think of a better group of people to have a panel on talking about speech AI. So I'm really excited to dig in with you all. And before we get into it, in a minute, each of you guys are going to be able to sort of present on what your company does and do a little bit more of a deep dive. But before we do, I wanted to kind of talk quickly about some of the terms that might come up and some of the basics. So first of all, you might hear some acronyms, things like ASR and TTS. ASR is automatic speech recognition, or also known as speech to text. That's when you speak and then it translates it into the text for you. TTS is text to speech, which is the reverse, where you would type something out and then it turns it into the speech for you. And then we're also going to talk a little bit about translation. We're going to talk a little bit about how this works with music. So we're going to talk a little bit how this works with things like music, things like sound effects. And we're gonna dive a little bit deeper into that stuff. There's so many use cases for this technology. We're gonna get into some of those use cases on this panel. So I'm excited to dig in. And let's just go ahead and get right into this with Shinji. If you have something that you want to share, if you want to go ahead and share your screen now would be the time to do it. Each panelist is going to have 4 minutes to sort of break down what their business is and their specialty and kind of talk about some of the things that they're experts in. And then once we finish the 4 minutes each, then we're going to dive into some fun roundtable topics and open up the discussion a little bit. So Shinji, if you want to go ahead and take it away.
So let me first explain my laboratory research activities. So we have a kind of 3 categories. One is that we call it machine listening, but which actually including many of the technologies that Matt mentioned, like speech recognition, speech enhancement, separation, speaker diarization, emotion, sound element classification, and so on. By combining everything, we can understand all the kind of audio environment, right? This, we call it machine listening, and this is one of our research labs activities. But this is not just kind of combining. We also working on each individual and then combining that. So similarly, our lab also focusing on lot for speech translation. This is also very cool technology, right? We can talk to the people in everyone with our languages. So this is actually a combination of the ASR, machine translation, and the TTS. That also already Matt mentioned. And the research phase is how to make it as a single end-to-end model to do it. And we are also working on it. And the other very exciting area is spoken dialogue system, like making a conversational AI, which is also similar to speech translation or machine listening. We need to combine various speech technology or natural language processing technology. So these kind of 3 components, we are mostly working as a research and development. And our lab in Carnegie Mellon is the one of the most active speech laboratories in the world. So, for example, we usually produce over 50 or 70 papers per year in the top conferences and so on. And we also usually are having a very good outcome, like a best paper or challenge top systems and so on. And we also maintain the open source the tools and so on. So this kind of activities mostly comes from my great the colleagues, student, and so on. This is just kind of one the picture of our colleagues, and of course it is the university. So every year the member is changed, but with this kind of great colleagues, the talented student, I can kind of actively working on this kind of speech area. And last, final comment is that yes, I was used to work on the industry, but now that moving to academia for a while. So in this sense, some part I have some kind of a difference with the real product system and some kind of research phases. But to connect this kind of area or to promote speech research, our lab is also working actively on the open source and ESPNet end-to-end speech processing toolkit. This is one of the most actively used speech AI toolkit now, and GitHub style is also quite large and many contributors, and also covering the ASR, TTS, transliteration, enhancement, diarization, almost all kind of speech techniques are covered. So if you are interested in working with us, please also ping me. That's it from me. Thank you.
Perfect. Thank you so much for that. All right, I'm going to go ahead and move it on over to Georg now, who is going to talk about what he's working on over at Suno.
Thank you. Yeah. So at Suno, we work on large generative GPT style models, but natively built for audio. So in the past couple of years, we've all seen tremendous progress in pretty much all of the big fields, but especially in images and text. And that's enabled these giant models, GPT, Stable Diffusion, that have been producing crazy results, and every few months the results are getting better and better. Within audio, there have also been amazing advances, a lot of them by Shinji, Alexei, and colleagues. And we're seeing a lot of advances also in efficient quantized audio representations. And that's something that personally I'm particularly excited about. And it enables a lot of technologies and borrowing from other existing technologies where a lot of progress has been made. So at Suno, our philosophy is sort of build a single model architecture that's able to generate arbitrary audio, and it shouldn't really matter whether it's speech, whether it's sound effects or music. And the idea is to then have that model and be able to scale it to LLM style sizes and see what it can do. So let me show briefly, maybe that's a little bit more illustrative, to show you some examples here. So the audio gods are favorable to us. So I'm going to show you the output of two different models. So note that under the hood, this is the same model architecture with just slight tweaks for the case of speech or text to speech, and for music, so text to music. So on the left side, we see our speech model we call Bark. And let me play a little output here of the text here, and that vocalized through the model.
The model is called Bark, like Clifford the Big Red Dog, or...
All right, so unfortunately the audio hides a little bit of the text, but what you can see is it's kind of interesting how the model ends up picking up everything from the text here. So it picks up punctuation, casing, it even picks up disfluencies such as bark or tree, and it very naturally produces audio that sounds very realistic, like a person is talking. You can even add instructions to this. So you can add these, what we call meta tags. So you can say things like sad, sighing, coughing, stuff like that. And maybe foreign languages also work, but maybe I'll play you this third example here because it's particularly sort of interesting for these end-to-end type applications. So you see from this paragraph, it's a little bit old advertisement soundy. Tired doom scrolling Twitter, try Soma. So it sounds a little bit like an old school advertisement. And it's kind of fascinating that when you type it in like that, the model not only vocalizes the text, but it sort of picks up on the fact that this should sound like an old advertisement. And so this is what the model produces.
Tired of doom scrolling Twitter, worried about the inevitable rise of our AI overlords? Try Soma, the miracle drug from Brave New World, brought to you by beloved Megacorp Jackson and Jackson.
Yeah, so it's really funny to see that to the model, it doesn't really make much of a difference if it's a very sort of rigid textbook style text or if it's something that could be set in any circumstance. And we can go a step further. We can now apply something similar to music. So I'll show you this first example on the left side where the input is some lyrics here at the bottom. And as well as, again, an instruction like this. In this case, the instruction can be used to steer the style of music so that the model understands, similar to like a Stable Diffusion or so, a description of the music. So.
Yeah, I've been trying to call. I've been on my own for long enough. Maybe you can show me how to love.
So you can see it picks up the country genre. It sort of nicely vocalizes everything, and as a both as a user but also as a machine learning practitioner, I don't have to worry about the differences of what's a melody, what's a background instrument, you know, who are the vocals by, is this a chorus, is this a single person, and instead the model just kind of makes up whatever it thinks is plausible for that input. Let me play maybe one more example just because it's fun. Here we have an upbeat EDM and other lyrics. So you can see it's fairly creative. Sometimes it'll choose to not entirely stick to the lyrics, or it'll elongate a syllable or something. But in a way, that's really nice because it means the model sort of has full creative control over just, you know, what would actually sound good. So I'll stop here. But you know, anybody who wants to play around, feel free to join our Discord. We always have the newest and most fun models there to play around with.
Absolutely. That's amazing, Georg. I've actually had the opportunity to play around with Chirp a little bit. I did like a theme song for my YouTube channel and made it in a hip hop version and a metal version. And it was really, really impressive what it can do. So thanks for sharing a little bit of behind the scenes, and excited to chat with you more when we get to the roundtable discussion. All right, I'm going to go ahead and pass it on over to Swapnil now.
Hey, so my company recently announced, you know, close to $1 billion worth of investment in Gen AI. It's been an exciting time ever since then, because there's tremendous interest in generative AI in Wipro, and you know, it's not something that we've started recently. There's a lot of research collaborations that have been you know, happening in generative AI in general for the last 3+ years with a lot of research institutes. We've been creating our own large language models for life sciences industries to start with. I lead the Generative AI Center of Excellence here and responsible for creating differentiated offerings in generative AI, whether it is speech, video, text, anything, right? So ever since the announcement of ChatGPT, I see there is a tremendous inflow of requests coming for speech AI and translation AI. One of the top use cases that I'm seeing for speech AI across all industries is around, you know, self-service assistants to deflect the calls coming to the live agents, right? So I see there's a huge demand for this because of the sheer volume of calls getting handled manually today. So there is a real value, and it really makes a business sense to use the speech AI here. Apart from that, the speech analysis for call quality assessment, that is also driving the interest in the ASR. Although there are a lot of solutions available in the market for this, but I've not seen the widespread use of it. Customers are reluctant to use the ASRs for a variety of reasons. The key challenge that I see in the widespread adoption in the current self-assist technology is you know, the lack of human-like responses, although there are, you know, natural TTS available, or the ASRs, which can recognize the languages pretty well. But what I mean by natural responses when it comes to especially the call center is, you know, most of the times these ASRs and TTS are, you know, working with some kind of a databases, and then, you know, gathering the output from there and presenting it to the end user. But what end user is really looking for are the solutions to their complex questions or the problems, right? And that's where we see that generative AI or the LLMs may have a role to play. And that's where I see a tremendous interest being generated because of these LLMs recently. There are a few interesting use cases me and my team has been working on around live speech analysis for content moderation in gaming, for instance, right? So there is a lot of hate speech, abuse, negative behavior happening in gaming world. And the gamer has to be, made aware that or warned immediately, right? If there is any foul language being used in the gaming. So this is like using speech AI to help promote the positive play in the gaming. That's what we're trying to work on. Another interesting use case is creating a virtual brand ambassador for a variety of customers, especially one of the large consumer brand where we're working on. Interestingly, the brand ambassador is not only for their website, but also for, we are creating a dedicated immersive experience centers on AR and VR devices. Now, the challenge there in those AR and VR devices is obviously the less memory footprint on those devices. So just to get the ASR and TTS onto those, it's a challenging thing. So the alternative solution that we've arrived at is, using the edge device, a separate edge server, to stream the audio from AR and VR devices to this local server, do the recognition and get back the results back to these devices. Similar to this, there is some work that we've done with large airports for, a 3D avatar on kiosk to answer passenger questions in 12 different languages. The idea here is to provide the navigation experience, provide wait times, restaurant information to the passengers there. Again, the entire ASR TTS is kept on kiosk on the local edge device to help address the latencies issues when it comes to streaming to the cloud. So overall, I see a very positive next year, at least for speech technology in general, because of the LLMs, and it has garnered a new interest. And I see a lot of demands coming from the customers.
Thank you, Swapnil. Appreciate that. Yeah, I was just recently reading an article the other day about how Call of Duty is actually introducing ASR to find people that are being abusive in the game. So it sounds like, very similar to the type of work that you're doing. So very interesting stuff. Thank you. Alexei?
I am senior principal scientist at Hippocratic AI, a recent startup. I would very much want to invite everybody to follow us on LinkedIn, to follow our press releases, and possibly join our lucrative partnership program that we have recently put together. So in exchange of data, external partners can participate in the company. So generally, if I would need to formulate the ultimate goal of the company, the goal is to develop a service of an automated conversational agent with specialization in nursing and medical information. So first of all, I have to say that we are doing a holistic design. We are not trying to improve any kind of technology. We are rather combining them, and through the combination, through the attempt to create a good interaction out of combination of those individual technologies, we also observe and see the existing gaps, the existing roadblocks, things that prevent us from declaring that problem being completely solved. So it's an engineering effort as much as a philosophical and scientific effort, because one of the necessary prerequisites to solve this problem is to, first of all, understand the place of the machine in the human-machine interaction. Shall we try to simulate another human with a machine? And well, depending on the situation, depending on the use case, there might be different answers to that question. Besides, we especially in high-stakes situation, in medical domain in particular, we need to solve a safety problem. So how safe it is to put a machine as the front end, interactive front end for the organization. We need somehow to implement a continuous quality assessment control and to be able to act upon the signals from such a system. Besides, we see that for most of the many sub-problems in this stack, the good data is not really available. Let me give you a simple example. The LLMs are very good at generating text, like a few paragraphs of it at a time. But if we want to build a conversational agent out of it, we immediately recognize that humans do not exchange paragraphs while interacting in the spoken domain. We somehow need to convert the semantic content and break it into pieces such that the pace of interaction is necessary pace of interaction is preserved, and all the conversation parties are in alignment, and they understand each other, and they're progressing towards mutual alignment, clarification, like common agenda, and so on and so forth. So another possible way forward is also finding a way for the machine to become adaptive. So we are building one design, but we want to apply to many use cases. And this machine that has a large language like model as a basis, it still needs to be adaptive to the practical particularities of each organization, each use case, and so on. Those machines are also need to be built to be adaptive through their own experience. And that's also a very big challenge. So with these host of the problems, we are trying to create a solution that at least partially will solve those problems for now. And we also work and look forward for interaction with academia to provide like a better solution to the problems that I have just mentioned.
Amazing. Thank you so much for sharing, everybody. This is going to be a fun discussion. We're going to kind of get into some live discussion here, and we've got some questions that we're all going to sort of jump in on and discuss. I want to remind anybody that's watching this that we will do a live Q&A at the end. So if you have questions for our panelists, you can either enter them in the chat as this is going, and we'll try to review them when we get to the live Q&A. Or once we're done, feel free to put your questions in the chat and we will get to them if we have enough time. But now we're going to go into some of the sort of pre-discussed roundtable discussions and have some fun. So the first question I'm actually going to put towards Alexei here, and it is, how do we take a simple idea and make brilliant things out of it?
Right, Matt. I think we shall approach it from the other from another side. So we shall approach it backwards. Instead of like having great idea and looking for the ways to implement it, we need to understand the current services, current technology, and see the imperfection of it. And then we can start hypothesizing, making some theories of how we can improve it. And then subsequently, we can look at the list of possible improvements and observe similarities in those improvements across that list. And that would allow us to re-rank that list and identify the most valuable technologies that need to be developed in order to have the biggest impact on the field in general. So I am now describing the algorithm of systematic search for useful improvements, technological advances that would lead to high impact new products. And our company adopts this way, and I would also want to hear other panelists, their opinions on the subject.
I actually have the comment and the question. First, I fully agree with the Alexei about, we should know what the things that behave and what kind of a problem that we should fit to our kind of a demand. And then I always recently have this kind of the struggling. Now the speech and all other technologies are little bit become a machine learning application, right? We used to know speech more. And then, we understand that, speech is, like, for example, sound, but converting the phoneme and then language model to kind of make some speech recognition. And then used to be, we know, what is happening. And then if, for example, we don't know that, oh, this word is not recognized, let's create a word and a dictionary and attach it and so on. And then we kind of, try to kind of make our problem, the speech recognition to be, for example, the product, the things. But nowadays, it's getting a kind of neural network, and then people even don't know the speech the knowledge, but speech recognition technology we can use and create and so on, right? So I'm actually sometimes struggling whether we should really know more about the speech, or since it takes time, so we can just skip this part and doing more for the machine learning, neural network engineering might be better. I'm actually struggling. Of course, in my side, I want people to learn the speech. But practically, maybe we should also, shift little bit more for this kind of the machine learning or neural network oriented the way of thinking. This is just a comment, but I just want to think, given your kind of great the idea, yeah.
Yeah, I would definitely like have a comment to Shinji's comment. I wonder if other panelists have their comments as well. I reserve a right to respond to Shinji's comment.
Yeah, I can maybe just to take a little bit sort of the other viewpoint. It's interesting how oftentimes in academia, it still ends up going the other way around, right? Because you see something that could be an improvement, you see something that is a clever idea, and you're like, I'm sure I can make this better. And then afterwards, you're like, okay, can I find an application for this, right? And even GPT, for example, is a great example for this, right? Like these language models, they were used for a lot of things, but then when people started to make neural language models and blowing them up in size, it was very cutesy, right? Like you could, I don't know, go to talk to transformers and have this thing, spit out something that sounded like a children's book with somebody who is, mildly drunk while writing it, and it wasn't really useful, right? And then this technology just kept getting better and better, all the way to emerging behavior, to the point where now we have a ChatGPT with almost unlimited applications here, right? So it's interesting to see how, exactly like you said, right? Like you often start from either end, and it ends up in an interesting place.
Alexei, did you want to? Oh, sorry. Go ahead.
No, I was saying I completely agree with what George just said, right? I mean, the LLMs are being around, they're coming, and there is a lot of interest that has been garnered around that. And today I see, I mean, whether it is speech-to-speech translation or text-to-speech, and everything has become kind of like a single model. You don't have to really know what's happening inside. You just throw a data set to it, and basically, voila, I mean, you get a beautiful output at times. And there are nuances, obviously, with that, but yeah, it's quite interesting how the technology has evolved.
Right. So I'll take just like a few seconds. So generally, referring to the Shinji's comment, shall we do science around human interaction, speech in particular, or shall we just adopt some machine learning methods that are progressively independent in their ability to capture this modality, interactive modality? I think we have to become a bit philosophical here, and take a note that with these large language models, we are kind of about to create a new silicon-based life form. And my philosophical claim would be that the sentient species that understand principles of their operation are further along the evolutionary line compared to sentient species that don't understand the principles of their existence, their operation. And I should probably have mentioned that speech is a window into how we think. So while studying speech interaction language, we also study how we think. And that is a necessary prerequisite for us to become the next evolutionary step. Not Homo sapiens, but Homo sapiens which knows the principles.
Cool, thank you. The time is just flying by, so we might actually cut back on a few of the questions that we were planning on asking, but I want to keep things moving along here. And my next question I'm going to direct at Swapnil, actually. So going from research to production, what works and what doesn't work? What are some of the current bottlenecks in using some of the super cool research models in production?
So most of the big enterprises seems to be aware of the cool research that is happening in speech and translation AI. I see, I mean, you know, for large enterprises, at least the speech and translation use cases are centered around the call center automation, because that's where they see their biggest interests are, you know, and that's where they're betting their big investments. So many of the enterprises, the large enterprises, do have their small internal teams to explore new technology in the market, right? So they're very fast in creating proof of concepts using this latest technology. For instance, if you take, let's say, a Meta's seamless M4T model, I mean, many of the customers that I met, they've already done some kind of a proof of concepts in their labs. But when it comes to the production implementation, that's where I see there is a huge struggle. It requires some serious engineering to migrate from proof of concept to the production. There are off-the-shelf products that are available, seems to address this problem to a great extent, but oftentimes they are very slow to adopt to the new technology due to their existing, you know, the product release plans. So whenever new model comes in, new exciting technology comes in, most often we see companies trying to, you know, implement their own version of the model, or maybe train their own model. So broadly speaking, I would say there are two types of challenges when we have to go to the production deployments. One set of challenges around the engineering aspects of these models. And the second challenge is around the model efficacy, you know, what most of the enterprises are concerned about. For engineering challenges, we look at it, you know, one of the key bottlenecks that I see is around the latency of the latest models that are coming out. Although there are approaches to improve the latency, but there are always trade-offs with respect to the accuracy versus the model size versus the cost of deployments, etc. Similarly, the edge deployments, the edge AI-based deployments are completely different ball games, and they require completely different approaches than the cloud-based models. Most of the models, when it comes to engineering, they come with the batch processing capability, for instance, and you have to do a significant engineering efforts to migrate them from batch processing to, you know, enabling the streaming feature around it. The model themselves may not be optimized at times for the GPU, CPU kind of an infrastructure. So the overall cost of ownership for the entire hardware becomes prohibitively high. For instance, you know, the unoptimized model inference pipelines. the multi-tenancy aspects comes into picture, the overall model isolation, the data isolations, things like that. They're pretty much important steps in order to go to the production. And one question that often we get asked from our customers is, how do you customize a new model? It's all fine, you're bringing in the new technology in here, but how we are going to customize this model for our requirement in future, right? And that's the question, that requires a bit of MLOps capability, the overall governance framework around the model to be in place before that model can be taken to the production. And oftentimes, some of the latest models are not really geared up for this. Another set of challenges that I talked about is about the efficacy of the models. That is also a key aspect while taking the models to the production. For instance, if there are, variations in the accents or the code mixed languages, if they're not handled well, then often the scope of the production deployments often gets curtailed or truncated because customers, they don't want to see, the models getting into production, but they do not have the the variations in the accents covered. So in that case, they basically limit the kind of use cases that model can handle, and this results in a partial benefits being given to the of the AI automation being used there. So even if these things are handled, for instance, the code mix language, there's great work that has happened. The accent handling, there's a lot of work that is happening out there. But even if these things are handled, there is a lack of test data around this often creates a problem when it goes to the production, and it also increases the release plan. And one last thing around the efficacy of the model, for instance, I've seen a lot of interest in the translation of late, being asked. However, the efficacy of the translation becomes an issue if you're reaching to the production deployment. And the main bottleneck in this is not the model itself, but there is complete unawareness of how to test the translated output. It's still a manual effort to do the validation of the translated output, and it requires the manual testing. And these are some of the the challenges that we see while taking a model from proof of concept to the production deployment.
Thank you for that. That was a very, very thorough answer. I think that answer covered a lot of ground. So I'm going to actually go ahead and move on to the next question, which I'm going to direct at Georg over here. And it's also very related to what you were just saying, but is there any difference between producing speech and nonverbal communication, like laughing, crying, singing, and even accents?
Yeah, it's a good question, and I'd be super interested in what the panel thinks about this. But kind of like I mentioned, we focus a lot of our research to try to treat all of this audio as equally as possible. So whether it's speech or background audio or these nonverbal communication tags or music, and all of that should be achieved maybe through some different training data, maybe some fine tuning, or just prompting. But ideally, you would want the model underneath it to be as capable as possible. And especially nowadays, where more and more of these models go end to end. And there's a limit, like Swapnil mentioned, there's a huge limit in training data for all these specific tasks, especially once you go really to these very particular applications of things. And so it's very important to have these things kind of baked into the base model. So ideally, the pre-training objective or something that is unsupervised, and you have a little bit more data available. And you can see this, for example, in the field of text-to-speech, where over the last, call it decade, where neural models have gotten better and better. The field has put a ton of work into adding things sort of one by one. Originally, it was capture natural speech patterns. Then we had to add speaker embeddings to get it to sound like a particular person. Then we wanted to add foreign languages, accents, and now it's adding emotions. And what about nonverbal communication? And all these things sort of become trickier and trickier, both from a data perspective, but also from a model architecture perspective, because you end up, adding new inputs, figuring out how to digest that information and putting it together. And in other fields like NLP, for example, right, the GPT model sort of learns all these things implicitly just through having seen enough data, and then you sort of coerce it in other ways, whether it's through emerging behavior, prompting, whatever sort of cool new techniques there are, to sort of capture that behavior that you're looking for. So I think it's going to be very interesting to see in the very near future how that's going to play out in speech. But I'd be curious to hear what other people are thinking about this.
Right. Oh, yeah, please, Shinji.
Go ahead. Go ahead, Alexei. Yeah.
Go ahead, Alexei, you start, and then we'll go to Sinji next.
Right. Okay. So thank you. So essentially, I have a very practical question. Like I'm looking at it from the practical perspective. So generally, the ability of a machine to synthesize any kind of audio is much richer than capability of our vocal apparatus. And as such, this creates a kind of a new modality of interaction between the human and the machine. So essentially, the machine can play a musical piece or like just a few notes to set some kind of appropriate mood. So my question to Georg would be, do you already often have requests from your clients for that kind of functionalities, that kind of extra human abilities, like in synthesis and effect generation? Like you can view them as special emojis for the spoken domain.
Yeah, there's definitely a lot of interesting use cases. I would say it's still very much in its infancy. So for most people, we're seeing interesting sort of peaks of some of this stuff, but it's very hard to really know what you can expect, right? So for example, how can you steer, like you just said, right? Like how can you steer the emotion of what's being said? Do you steer that through the way that you write the sentence? Do you steer this through literal instructions where you say, sad man speaking in, slow tone, sigh, and then what they're saying? Or do you start, for example, by giving it, a couple of seconds of sad music in the beginning, and then you give it a TTS prompt, right? And in principle, all of these, work for the model if it's seen that type of an input data. So I don't think I have a fantastic answer, but I think that's exactly the kind of thing that it's becoming really interesting right now to start to probe and see, what are the interesting applications of this and how can you best use this?
Sinji, did you have a comment there?
Sure. First, I really like the Georg's kind of the way of the thinking and the direction. And currently, many of the speech, the self-supervised learning model, they are actually more like try to kind of define the information, right? From the audio to define the information, which is more like a semantic information or contextual information, and then it can be used for the powerful the speech recognition, the speaker recognition, the techniques and so on. But as Georg mentioned, definement is actually losing some information, right? Definement is in terms of if we're using the speech technology, we should define, we should remove the noise and so on. But if we want to use the noise to understand the environment, if we want to use, for example, punctuation information so that the data natural language processing can well handle the, for example, sentence level, the application and so on, we do not have to kind of remove this kind of information, right? So then probably not actually this is new. Actually, many people are now moving to this direction. We should work more for the disentanglement, working on the self-supervised learning model more, but probably we should have more kind of information disentanglement in the middle with some implicit modeling or explicit modeling so that we can have a kind of rich information of the decomposition of speech, not only for the spoken contents, but the environment or all other kind of information, and then generating some kind of the original the data. I am very sure that this direction will become more kind of popular. And then in this kind of cases, what you mentioned would be the more realistic. We can easily scale to the very large speech and audio data to get this kind of disentanglement information, and then we can use it for our kind of the various applications. And even this encoder information can be unified so that can deal with all of such kind of applications. I'm sure that this kind of direction will happen. And already audio codec and so on is a kind of doing something similar, right? But I'm very expecting that this direction would be more the advanced. Yeah.
Amazing. Well, we've got time for one more question, and I want to make sure that anybody who's tuning into this has some sort of practical takeaway that they can go away with. So this question is going to be directed at everybody, and we'll kind of go around the room here, and I'm going to start with Shinji. But what advice would you give to a business that is considering implementing some sort of speech AI into their business?
Okay, so probably the other people have a more practical advice, but my kind of the advice is that we should also try to kind of disclose our kind of knowledge and the making the community entire community happy. So I mean, I'm very sure that I really understand the company's the stance of developing something and then hiding some information and so on, which is one way we should definitely do. But someone also has to kind of disclose, for example, technique by writing the paper, or even open source the data and so on, which is kind of should be complementary. And my kind of it's not like the advice or more like the suggestion or hope it would happen is that such kind of industrial kind of the advancing of the technologies, and then the community also kind of growing to understanding the speech and the translation AI should be kind of evolved. That I am kind of at an academia to kind of help this kind of part in addition to our kind of colleagues in the industry. Yeah.
Thank you. Georg?
Sure, yeah, and we Swapnil has mentioned this very eloquently before, but I think spend a lot of your time and effort to evaluation, both from a data set perspective, try to be as diverse, really covering the exact needs that you have, as well as the models that you're using, and really spend only once you've tested 10 different existing implementations and you really know why certain ones of those are better or worse than others, only then sort of take the next step on whether you want to implement something in-house or get some other resources to really go further. Still now I make that mistake all the time, that I get too excited about implementing something and then I make 3 different versions and then I realize I can't even really evaluate which of these 3 is different in what way. So definitely always a good important thing.
Swapnil?
Yeah, completely second with Shinji, right? So basically, what I also believe, some set of industries, so whether it is, the payer industry or, the life sciences or the BFSI sector for that matter, all the industries, if they come together and then try to create a domain-specific data, maybe 50% of their data, if they can share in the community, that would be great, right? To build these models alongside academia. And you can basically have a base model created specifically for each industry. There is a set of data today available, but it is not enough to, kind of do a research that is needed to really scale these models.
Thank you. And Alexei, any advice?
Right. I'm risking here to give an ill advice, because take this with a grain of salt, because this advice comes from a scientist to a businessman. So I am not a businessman myself, so I'm not responsible for the results of my advising. So that's the disclaimer. But I would say that the most basic realization that a new starting business need to make is that there is absolutely no point in competing with existing technologies. So you cannot become a better chess player at this point. Like current information technology is so complex, so intricate, is so advanced that there is no point to catch up, and there is no way to catch up. You need to invent your own chess if you want to succeed.
I think that's great advice, and I think that's a great way to go ahead and end this panel. And we are going to open it up to Q&A now for the people that are hanging out on this live. We're going to go ahead and start taking questions from the audience. So thanks, everybody, for the discussion so far.
So I hope you have enjoyed so far. Our esteemed speakers and panelists tried to answer many of your questions as well while the other people were talking. And I want to say that Matt needed to step away to catch a flight. So we're going to continue with answering your questions. And there is one question that was talking about cloning technology. We see a lot of progress in voice cloning technology, and they would like to hear opinion of these panelists. What are you thinking actually about the safety and security, both in the infrastructure level and the industry level and the computer level? So anybody wants to take on that to start first?
Sure, I'm happy to start briefly, maybe. Maybe two ways to think about it is the sort of the technological perspective of voice cloning and then the moral safety perspective of voice cloning. I would say from a technological perspective, it first depends a little bit on the definition, which is interesting. So one way that you could say voice cloning could be defined is to basically say, I would like a computer to just continue my current speech. So it should sound the same, it should have the same feeling and just kind of continue speaking the same. And then another one would be to say, I want to extract something specific about a voice. So for example, I want the representation of that person, but then I should be able to let them be happy, let them be sad, talk at a different speed, et cetera, et cetera. Both of those are things that are heavily being worked on. And I think both of those, to be honest, they're all in a fairly good spot from a technological perspective. You know, yes, people sound somewhat different, but people also don't sound that different from each other. So usually algorithms that are trained on enough speech tend to be fairly decent at emulating an unseen human, even if they weren't in the training set. From the moral perspective, of course, that's a potentially huge problem. I mean, we went through this with images, right? That you know, 50 years ago, you saw an image, or 20 years ago, even you saw an image, and you believe this to be the truth. You see this in the newspaper, right? And nowadays we see pictures on social media that may just not be real. And I think for audio, we're at a point where people are not going to make that jump yet. So if people hear something, they still think that this is something that's real and has truly happened. So I think that's definitely something that will be an issue in the next few years, and that's why. From a commercial perspective and even open source perspective, there has been a lot of effort in trying to not allow easy voice cloning of people. So most of these algorithms that are trained, yeah, it's very easy. It's very easy to just take somebody's voice and just keep letting them predict something. But in almost all applications, that's sort of actively suppressed through various different means.
Thank you, Derek. Is there anybody else that would like to add something, or we can jump to the next question?
I can say something. Yeah, as Derek mentioned, in the research field, these kind of the things are quite kind of actively studied, especially there are a lot of kind of a series of the challenges called the spoofing challenge, which tries to kind of detect the cloning technique in the various range of the techniques. But of course, you know, it is not never-ending story. If you know people started to detect, there are several other kind of the cloning techniques to kind of avoid this kind of detection method. So I think this kind of the technological the interactions will continue, but it's like you know, we are developing the wheels, the computer wheels. I'm very sure that people can just kind of have a way to avoid these kind of issues by putting the computer wheels, the detection-like techniques in everywhere when we try to kind of capture the audio information. That is my guess.
Thank you. And I hope that we answer most of the questions. We have like a minute or two. So I would like to, have this question for everybody to share their opinion. And that would be about what would be the useful products that would stick around? What do you think? Right. Jinjin, do you want to start?
Sure. I think it's also that I want to see the kind of the near future the technical trend. So probably many of the speech technologies can be solved by one single model. Even the ASR, TTS, speaker identification, language identification, speaker recognition, speaker diarization, all of the techniques, voice conversion, voice cloning as well. I'm very sure that in the future, all the model can be represented by the single model. That is my actually expectation. So this actually could change a lot of design of our the infrastructure and the software and so on. But similar things happen to the language model side as well. So this is actually my comment.
Thank you. Anybody else wants to add before we close?
Yeah, I agree. I mean, I would love to hear from the audience what the things are that seem like repeated tasks and not just sort of interesting. Because in academia, we often get sort of, we find something difficult and then we try to solve it. So it's always great to hear from actual users and others in the field what are the things that seem like they are a fundamentally useful thing and not just a technology.
So it's up to you, audience, to put your answer to this ask from Georg into the chat. And Alexei, I think you wanted to add something too.
Yeah. There's another question that actually close and is a development of what has been just discussed and what Shinji just mentioned. So the audience asks, what is your current thought on the state of speaker diarization? So generally, this field has been developed through the years, and a lot of useful algorithms were proposed. But like if we take this diarization problem a little bit wider and talk about acoustic scene analysis and generally solving cocktail party effect, where you have a mixture of multiple non-stationary sources. Some of them may be speakers, some others may be some machinery producing noises in the background. So like objective comparison between the human level and the machine level in this task points to human superiority in this task yet. So like fundamentally, we don't really yet understand how humans are capable of doing what they apparently able to do. And like it looks like we cannot follow more than one speaker at a time. And like the promise is that the machine, as it gets more complex, can actually solve that problem too. So I would expect technological progress in that field to the point where machines not only catch up, but also supersede humans in their ability to decipher individual non-stationary sources in the mixture and following them collectively simultaneously.
So thank you, Alexei. And before closing, Swapnil, maybe you can add a few words too.
Sure, and I completely agree with what Shinji just said, right? So there is a way for multimodal kind of a model to be there for which includes both the ASR, TTS, the language aspect combined into one, including the cloning. However, I'm looking at it from the industry perspective. As soon as you have the model, which is bigger one, then it has its own problem of how do we train the model, or suppose we have to train only the ASR aspect of it, not touch on the other aspects. Are we going to do that? And this is quite exciting and interesting how we are going to proceed in that area in the next maybe months or years to come.
So thank you, Swapnil. And I want to thank first to our panelists for being here and for all of you who are attending this panel. And to say that if you miss any part of it, the recording will be available within 24 hours. And if you're curious to hear more about speech and translation AI, there's the next session. So please join experts for Motorola and SoftServe to learn more about the best practices. So thank you all.
Thank you very much.